Gas Laws by Desiree Laura Neri and Briseida Villalobos. Kinetic molecular theory, also known as KMT, is how gases should behave. This says that the properties of gases are determined by the kinetic energy of the particles only. This is very different than solids and liquids.
Ideal versus real gases. Ideal gases follow the kinetic molecular theory while real gases don't. Ideal gases don't exist under most conditions. Many real gases behave like ideal gases. Also, real gases behave differently than ideal gases under conditions of low temperature and very high pressure.
The factors affecting gas behavior include mass, volume, temperature, and pressure.
Gases are measured in Kelvin. In order to convert from Celsius to Kelvin, add 273. In order to convert back to Celsius, you subtract 273.
Boyle's law states that the volume of a gas increases as the pressure of a gas decreases, and vice versa. The equation is P1V1 equals P2V2. A gas occupies a volume of 458 milliliters at a pressure of 1.01 kPa and a temperature of 23 degrees Celsius. When the pressure is changed, the volume becomes 477 milliliters. What's the new pressure? Gee, how does this work? Well, let me show you. First, you start out by writing your givens. Now you will solve for P2 by using P1 times V1 equals P2 times V2. After solving, you find that P2 equals 0.97 kPa.
Real-life example of Boyle's law. A few marshmallows are placed in a syringe, then someone holds their thumb over the tip of the syringe and they push the syringe in and out. Pushing in the syringe causes pressure inside to increase as the volume of the marshmallow decreases. Pulling out the syringe does the opposite effect.
Charles states the volume of a gas is directly proportional to its temperature as long as its pressure remains constant. The equation is V1 divided by T1 equals V2 divided by T2. Given 100 milliliters of hydrogen gas collected when the temperature is 27 degrees Celsius, how many milliliters will the hydrogen occupy at 42 degrees Celsius? Now what? Now we solve. As before, find your givens. Now you will solve for V2 using V1 divided by T1 equals V2 divided by T2. And you find that V2 equals 105 milliliters.
Real-life example of Charles's law. A balloon is inflated just enough to fit in a beaker. Its radius is then measured before being placed in a beaker of boiling water. After a few minutes, the hot balloon is removed from the beaker and its radius is measured again. After heating, the volume of the balloon increased because the heat caused the balloon to inflate with air. Gay-Lussac's law states that a volume occupied by a gas at a constant pressure is directly proportional to the absolute temperature. The equation is P1 divided by T1 equals P2 divided by T2. Now determine the pressure change when a constant volume of gas at 1 atm is heated from 20 degrees Celsius to 30 degrees Celsius.
Don't worry, I'll help. Once again, you start with your givens. Don't forget to make the temperature into kelvins. Now solve for P2 using the equation P1 over T1 equals P2 over T2. Then you will find that P2 equals 1.03 atm.
Real-life example of Gay-Lussac's law. A water-filled soda can is heated until water boils. Then using the tongs, the soda can is quickly plunged upside down into an ice bath. This results in the can being crushed. Doing this causes the temperature and pressure inside the can to decrease, causing the outside pressure to be greater than the inside pressure, which is why the can was crushed. Combined gas law. A gas law that combines Charles's law, Boyle's law, and Gay-Lussac's law. The equation is P1 times V1 over T1 equals P2 times V2 over T2. This is an example that we will further explain in the next slide using the combined gas law.
What? It's so easy! Write down every single one of your givens and then set up the equation P1 times V1 divided by T1 equals P2 times V2 divided by T2 and cross multiply to find V2, which turns out to be 2.76 liters. Ideal gases and imaginary gases, particles are infinitely small and do not interact with each other. The equation is PV equals nRT and it takes into account all the variables that affect gases. R is calculated from STP and the units of equation are R equals ATM times liters divided by moles times K. Graham's law of diffusion states that the diffusion rate of a gas is inversely proportional to the square root of its molecular mass. Example: if oxygen molecules diffuse at an average rate of 3 moles per second, how fast would hydrogen molecules diffuse in the same exact condition? So first you take what was given to you in the previous problem, and then you plug it into the Graham's law of diffusion equation, and after a few calculations you'll get that the speed of gas A was 12 moles per second, which is 4 times faster than the speed of gas B. What do you recall from this lesson? Oh, I know! For Boyle's law, as pressure goes up, volume goes down. And for Charles's law, as temperature rises, volume rises as well. And finally, Gay-Lussac's law, as pressure rises, temperature rises too. And they all come together to form the combined gas law. So, yay, we're done! Yeah, woohoo! You know what? This was awesome. Thanks for watching!
Created using Powtoon.